All right, welcome to another deep dive
Yeah,
into some fascinating computer science concepts.
absolutely.
And today we're going to be tackling a pretty fundamental one, lists.
Yeah, lists are everywhere.
Yeah, you can't really escape them if you're going to do any kind of programming or coding.
And they underpin so many other data structures as well.
Exactly. So we're going to try to lay a really solid foundation today for our learner
For sure.
who pointed us to this Code Curious YouTube channel, which is really focused on this idea of pseudocode.
Yeah, I really like their approach with the pseudocode because it helps you focus on those core principles that apply across all these different programming languages.
Yeah, you don't get bogged down in the syntax of, is it a curly bracket here or is it parentheses there?
Right, or should there be a semicolon?
Exactly,
Yeah.
all that kind of stuff.
Right,
So,
yeah, okay.
so what we're going to try to do today is look at how lists are actually manipulated
Okay.
and how you can use them and think about them.
Yep.
So we'll start with looking at how to get to particular items within a list. That's this idea of indexing.
Right.
And then we'll go on to, some common actions that you can do with lists, like sticking new things in them, sticking things at the end of them,
Right.
taking things out of them,
Yeah.
and figuring out how many things are in them.
Right.
And then we'll look at this idea of how to step through a list that's called traversing. And then we'll even look at some examples of how lists are used in common algorithms.
Sounds like a great plan.
Yeah, so by the end of this, hopefully you'll have that solid understanding of lists. You'll have
Okay.
those aha moments.
That's what we're hoping for.
Yeah, and you won't feel overwhelmed.
Oh, sure.
So let's jump in.
Okay.
Let's start with the most basic thing.
Sure.
How do we actually get to individual items within a list?
Okay.
And this is where indexing comes in.
Right.
Think of a list as just, a line of items. And each item has a particular address.
Right.
It's position in line, and that's the index.
Got it.
Now, one thing to notice
Yeah.
with this Code Curious material
Mm-hmm.
is that a lot of their examples are actually one-based indexing.
Okay.
And what that means is they start counting at 1 for the first item.
Interesting.
Whereas in a lot of programming languages, you actually start counting from 0.
Okay, got it.
So it's just something to be aware of.
Right.
Different systems might use different starting points for their counting.
Yeah, I guess that makes sense.
But the fundamental idea is the same.
Right.
The index tells you where to go.
Right. It gives you access to that specific element in the list
Exactly.
based on its position.
Now, the way they represent this in their pseudocode is a couple of ways.
Okay.
So one is they'll actually just use text.
Okay.
So if you have a list called a list,
Right.
you can say list, and then in square brackets, you put the index.
Okay.
So let's say it's I. So you'd say a list,
Okay.
square brackets, I. The other way they'll do it is they'll have a little rectangle, and they'll have, that I inside the rectangle.
Right. I saw that.
But it's really all the same.
Yeah, just different representations of that idea.
Exactly. It's
Yeah.
just saying this is how I want to get to this particular thing.
Right.
Now, once you have an index,
Okay.
you can actually start to do stuff with it.
Right.
So you can assign the value of that element to a variable.
Okay.
And they show this, they use this colon equals
Right.
to do assignment.
Got it.
So they might say, x colon equals a list, brackets I.
Okay, so the value at that I position in a list gets copied into X.
Exactly.
Okay.
You can also do it the other way around.
Oh, really?
You could say, a list, brackets I colon, equals some value.
Okay, so now we're taking a value we have and putting it into the list.
Exactly. So you're actually changing the contents of the list.
Got it.
Now, what's really interesting is they show an example where they say a list brackets, I colon equals a list brackets, J.
Okay, so we're working with the same list here.
Yeah. We're taking the value at one index
Right.
and putting it into another index.
Okay, so you could think of it as like moving data around within the list.
Exactly.
Got it.
So it's really powerful.
Yeah. You've got a lot of control.
Yeah.
You're not just retrieving information, you can actually manipulate the list as well.
Exactly.
Okay, yeah.
All right. So we've talked about now how we can get into the list.
Right.
We can get at individual items.
Yep.
Let's talk about some common actions you can do on the list.
Okay.
And they call these procedures.
All right.
So one of them is insert.
Okay.
And they have this pseudocode that looks like insert parentheses, a list, comma I, comma value.
Okay, so we're inserting a new value into the list at a specific index I have.
And the key thing to remember about insert
Yeah.
is that it actually shifts everything else. over to the right.
So it makes space for the new item.
Exactly. It makes
Mhm.
physical space.
Got it.
So you're not just overwriting something. You're actually
Yeah.
making room for something new.
That makes sense.
And then we have this other procedure called append.
Okay.
And that one looks like append, parentheses, a list, comma, value.
So I'm guessing this one adds the value to the end of the list.
Exactly.
Okay.
You don't have to specify an index with this one.
Right, because it just goes to the end.
Exactly. Just tacks it on at the very end.
Got it.
And then for removing things,
Okay.
we got remove.
Okay.
And that one looks like remove, parentheses, a list, comma, I.
Okay, so this one's the opposite of insert.
Yeah, so it's going to delete something
Right,
in a particular index
Okay.
and then shift everything else to the left.
Okay, so it shrinks the list and moves everything over.
Exactly.
Got it.
And then the last procedure we're going to talk about is length.
Okay, that sounds pretty self-explanatory.
Yeah, length, parentheses, a list.
So this just tells you how many things are in the list.
Exactly.
Okay.
It just gives you a number back.
Got it.
So pretty straightforward.
Yeah.
Okay, so now we've looked at how we can get into a list.
Right.
We can grab particular items.
Mm-hmm.
We can do some actions on the whole list.
Yep.
Let's look at this idea of traversing.
Okay.
What does it mean to traverse a list?
So traversing means going through the list element by element.
Exactly.
One by one.
So you're essentially visiting every item
Yep.
in the list.
Uh-huh.
And they point out you can either do this completely,
Okay.
like look at every single item in the list.
Like a complete traversal.
Exactly.
Uh-huh.
Or you could just look at a subset.
Okay, so maybe based on some condition or something like that.
Exactly.
Got it.
And the way that you actually do this in code is using something called iteration.
Okay.
And they show this pseudocode that looks like this. For each space item, space, in space, a list.
Okay, so we're going through each item within the list.
Exactly. So for every element that's in a list,
Mm-hmm.
it assigns that element to this variable called item.
Uh-huh.
And then it executes the code that's inside the loop.
Okay, so you can do something with each item as you visit it.
Exactly.
Got it.
And then they emphasize these iteration statements
Okay.
are really how you implement these traversals.
Right, makes sense.
All right, so now we have a pretty good idea of how to access, modify,
Uh-huh.
and even iterate through these lists.
Yep.
So now for, I think, the really interesting part,
Okay.
which is how are lists actually used in algorithms?
Right, the practical application.
Exactly.
Yeah.
And they provide a few really nice illustrative examples.
Okay, great.
So let's start with something simple.
All right.
How do we find the minimum value within a list?
Okay.
So the basic idea is you start with a variable
Okay.
that's going to hold your minimum value.
Mm-hmm.
And often what you'll do is you'll set that to the first element in the list.
Okay, so you're assuming initially that the first element is the smallest.
Exactly.
Got it.
And then you step through the rest of the list.
Okay.
And for each element, you compare it to your current minimum.
Right.
And if you find something that's smaller,
Huh?
you update your minimum.
Got it. So you're constantly comparing and updating as you go through the list.
Exactly.
Yeah.
And at the end of that process, your variable should hold the absolute minimum.
That makes sense.
Now, the example code they give is they have a list called nums.
Okay.
And it's got these numbers in it, 65, 89, 92, 35, 84, 78, 28, and 75.
Okay.
And then they set a variable called min
Right.
to nums brackets 1.
Okay, so remember they're using one-based indexing here?
Exactly. So min starts at 65.
Got it.
And then they have this loop that says for each score in nums.
Okay, so we're going to look at each number in the list.
Exactly. And inside the loop, they have this condition. If score is less than min,
Uh-huh.
then they say min : equals score.
So if we find a number smaller than our current minimum, we update min.
Exactly. And then at the end, they say display min.
Okay, so let's actually walk through a couple of iterations of this.
Yeah, let's see it in action.
All right, so initially our min is set to 65, right?
Right.
So the loop starts, it looks at the first score, which is also 65. Is 65 less than 65? No, it's equal.
Nope.
So min stays the same.
Right.
The next score is 89.
Uh-huh.
Is 89 less than 65? Nope.
Wrong.
We move on 92.
Uh-huh.
Still not less than 65.
Okay.
Now we hit 35.
Uh-huh.
Is 35 less than 65? Yes, it is.
Yes.
So now we update min to be 35.
Okay.
We keep going 84, not less than 35, 78, not less than 35.
Huh?
But then we get to 28. Is 28 less than 35? Yes.
Yes.
So we update again. Now it's 28.
Okay.
And finally, 75 is not less than 28.
Right.
The loop finishes, and
Right.
what gets displayed? 28.
28.
Which is the smallest number in that list.
Exactly.
Yeah.
Okay, so that's a very simple example, but it illustrates the idea.
Yeah, you can see how the loop and the conditional statement work together to find that minimum value.
Exactly. Let's look at another task.
Okay.
How would we find the sum of all the even numbers in a list?
Okay, so for this one, you typically start with a variable to keep track of the sum.
Right.
And you'd initialize it to 0.
Okay.
Then you'd loop through each number in the list.
Uh-huh.
And for each number, you'd need to check if it's even.
Right. How do we do that?
Well, they use the modulo operator,
Okay.
which is represented by a modi.
Okay.
So if you have a number, let's say score, so
Yeah.
modi 2 will give you the remainder after dividing score by 2.
Okay.
So if the remainder is 0, then the number is even.
Right, because it's perfectly divisible by 2.
Exactly.
Okay.
So if the number is even, you add it to your sum.
Okay.
And after you've gone through the whole list, your sum variable will hold the total of all the even numbers.
Got it.
Okay.
The example code they give is, again, they have a list called nums,
Oh.
and it's got these numbers 5, 3, 8, 4, 7, 2, 1, and 10.
Okay.
And they initialize a variable called sum to 0.
Right. Starting point.
Exactly. And then they have this loop for each score in nums.
Okay, same as before we're going through each
Yes,
number, right?
And inside the loop, they have this condition e score malo 2 equals 0.
Right, so that's checking if the number is even.
Exactly.
Yeah.
And if that's true, they say sum colon equals sum plus score.
So we're adding the even number to our running total.
Exactly.
Yay.
And then at the end, they just display sum.
All right, let's trace through a few steps of this one too.
Okay, so we start with sum at 0.
Right.
And the first number we look at is 5.
Uh-huh.
So 5 mod 2,
Gives us 1.
which is not 0.
Right, so 5 is not even, so we don't add it to the sum.
Exactly. So sum remains 0.
Okay, next number is 3.
Uh-huh.
3 mod 2 is also 1.
Right.
So sum is still 0.
Okay, now we get to 8.
Okay.
8 moldy 2.
Is 0.
0. So what happens?
We add 8 to our sum, so now sum is 8.
Okay, great.
Next we have 4.
Uh,
4 mod 2 is 0.
0.
So we add 4 to the sum.
So now it's 12.
Exactly. 7 is odd, so we skip it. 2 is even, so we add it to the sum, making it 14. 1 is odd, we skip it, and finally 10 is even, so we add 10, making the final sum 24.
24.
And that's the correct sum of all the even numbers in our list.
Exactly.
Oh.
Okay, so those are 2 examples of how you can use these lists to do some calculations.
Right, combining loops and conditional statements.
Exactly.
Uh-huh.
The last algorithmic idea that they touch on is this idea of linear search.
Oh, okay, I've heard of that one.
Yeah, it's a pretty basic search algorithm.
So what's the basic idea behind it?
It's really just about going through the list one item at a time
Okay.
and checking if that item is what you're looking for.
Right, so you're just going in order.
Exactly, sequentially.
Uh-huh.
So you start at the beginning of the list,
Yeah.
and you just check each item. And if you find it,
Uh-huh.
you're done.
You found what you're looking for.
Exactly.
And if you get to the end of the list and you haven't found it,
Then it's not there.
it's not there.
Now, the example they give is they have this list of new members,
Okay.
and they want to find a particular key name.
Right.
And they initialize a variable called index of name to -1.
-1. Why -1?
Well, -1 is just a way to indicate that the name hasn't been found yet.
Oh, okay, so it's like a flag.
Exactly.
Got it.
And then as they go through the new members list,
Right.
if they find the key name,
Uh-huh.
they'll update that index of name variable.
Okay, so it will now hold the actual index where the name was found.
Exactly.
And if they don't find it,
It stays at -1.
stays at -1, indicating it wasn't in the list.
Exactly.
Okay, that makes sense.
And the way they do this is they probably have a loop that goes through each member
Right.
of the new members list.
Uh-huh.
And then they have a condition inside the loop to check if the current member matches the key name.
Okay.
And if it does, then they update that index of name variable.
Got it.
All right, so that's the idea of linear search.
Pretty straightforward.
Yeah, just going one by one.
Uh-huh.
All right, now the last thing we're going to talk about
Okay.
is this idea of interpreting and predicting the output of code.
All right.
when you have lists involved.
Yeah, that can be tricky,
It can be.
especially when you're first starting out.
Yeah, you really have to think carefully about how those lists are changing as the code is running.
Exactly.
And they give us a couple good examples to illustrate this.
Okay, great.
So one of them is they have this list of words.
Right.
And it starts out with old, care, unusual, bold, far away.
Okay.
And the code is going to go through and remove any word that has a length of 3.
Okay, so we're going to be shrinking this list.
Exactly. So as they walk through this, old has length 3, so it's removed.
Okay.
Also, length 3 gets removed.
Gone.
Unusual is longer than 3, so it stays.
Stays.
Bold is 4 letters.
Stays borrowed.
3, it's out.
Okay.
And then away, 4 letters, it stays.
Okay, so we end up with unusual, bold, away.
Exactly.
Got it.
Now, what's a common mistake people might make when they're trying to think about this?
Well, I think a lot of people forget that when you remove an element from a list, everything else shifts over
Yes.
to the left.
Yes.
And their indices change.
Exactly. So if you're not careful with your Luke,
Right.
you might actually skip over elements.
Oh, okay. So if you remove an element at a certain index and then you just move on to the next index, you might miss the element that's now shifted into that position.
Exactly.
Yes.
So they really emphasize how that list is changing.
Right. It's dynamic.
Yeah, as the code is running.
Yeah.
Okay, the other example they give with the words list
Yeah.
is they start with songbook, video book, and this time they're going to insert
Oh.
instead of remove.
Interesting.
And they have a loop that runs a fixed number of times,
Okay.
equal to the initial length of the list.
So 4 times in this case.
Exactly.
Right.
And what they're going to do is they're going to look for the word book,
Uh-huh.
and every time they find the word book, they're going to insert the word read before it read.
Okay, so we're going to end up with more books and more reads.
Exactly.
All right.
So let's see how this works.
Okay.
So the first time through the loop,
Yeah.
they find book at index 2.
Okay.
Remember, 1 based indexing.
Right.
So they insert read before it.
So now the list is song, read, book, video book.
Exactly. And then the loop continues.
Right.
And they find book again.
Uh-huh.
But now it's at index 5.
Right, because we inserted read.
Exactly.
Uh-huh.
So they insert read before that one too.
So now we have song, read, book, video, read, book. Okay, so the list has grown.
Yeah, it's gone from 4 items to 6 items.
Right, and the loop was only set to run 4 times.
But it still processed those extra items.
Interesting.
Yeah, it's because it's checking the condition each time through the loop.
Right, so even though the list is changing, the loop is still looking at every element.
Exactly.
Got it.
So this really shows how insertion
Yeah.
can change the structure of the list.
Right, both the content and the size.
Exactly as the code is running.
Mm-hmm.
So it's important to really trace through those changes
Yeah, you have to pay attention to the detail.
to make sure you understand what the final output's going to be.
Absolutely.
Okay, so let's just recap what we've talked about.
Okay.
Drawing from this Code Curious material.
Right.
We started with looking at indexing.
Mm-hmm.
How do we get at those individual elements within a list?
Yeah, using their position.
And then we looked at some common procedures
Yeah.
like insert,
Mm-hmm.
append,
Move.
remove, and length.
Right, those are the building blocks for working with lists.
Exactly.
Yeah.
And then we talked about iteration,
Uh-huh.
specifically this for each loop.
Right, for traversing through the list.
Exactly, for going through each item one by one.
Uh-huh.
And then we looked at some examples of actual algorithms
Yeah.
that use lists like finding the minimum value,
Yep.
summing the even numbers,
And linear search.
linear search.
Uh-huh.
And finally, we talked about the importance of really being able to trace through code
Yes,
and predict the output.
absolutely. Especially when you're dealing with modifications like insertions and removals.
Exactly.
Yeah.
So hopefully you, our learner now, have a better understanding of how these lists work
Definitely.
and why they're so important in computer science.
They're really fundamental.
They are.
Yeah.
So as you continue your journey,
Uh-huh.
I want you to think about how could you combine
Okay.
these basic operations that we've talked about
Right.
to do even more complex things.
Like what kind of things?
Well, what about sorting a list?
Okay.
From smallest to largest or largest to smallest.
Right, or maybe searching for patterns in a large data set.
Exactly.
That would be cool.
Yeah. A lot of real world problems
Uh-huh.
can be solved using these ideas of lists.
Yeah. It's amazing how these basic concepts can be applied in so many different areas.
Exactly. So from managing your to-do list
Right.
to processing data in the cloud. It's all based on these fundamental ideas.
Absolutely.
So yeah, I hope this has given you some food for thought.
Definitely.
And good luck with your future coding endeavors.
Good luck.